This time I'm going to talk about homework 8, question 2. It says that let n be a Poisson process with parameter lambda, that is, probability of n, the number of random points arrives in interval t1, t2 equals to k equals to e to the power of minus lambda multiply t1 minus t2 multiply lambda t2 minus t1 to the power of k over factorial k. Now we define a new stochastic process that as xt equals to 1 if n is odd in interval t to t, 0 to t, and it equals to minus 1 if n is even in time interval t to 0 to t, which like this. The first question is to find probability xt equals to 1. So we know the Taylor equation that e to the power of lambda t equals to 1 plus lambda t plus lambda t squared over 2 factorial 2 plus lambda t to the power of 3 over factorial 3 plus blah 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 blah. And we also know that e to the power minus lambda t equals to 1 minus lambda t plus lambda t squared over 2 factorial 2 minus lambda t to the power of 3 over factorial of 3 plus blah blah blah. And we know if we minus the above two equation, we can get that to the even index of above equation. And if we multiply e to the power of minus lambda t on both sides of the equation, we get the right side equals to e minus lambda t e to the power of minus lambda t. Multiply the even index part of the above question, and we observe that it equals to the summation of the Poisson process equation, where the k is odd and xt equals to 1, and we can get the probability. It just equals to 1 minus e to the power of minus 2 lambda t over 2. So the second question is ask us to find the expectation of ext. We also know in the first question the e to the power of lambda t and e to the power of minus lambda t. If we add them up, we can get the odd index part multiplied by 2. If we multiply e to the power of minus lambda t on both sides, we can get that the equation of probability of xt equals to minus 1. So the both situations is represented, and we can just use them to get the expectation of xt, which equals to positive 1 multiply the probability xt equals to 1 plus the minus 1 multiply the probability of xt equals to minus 1. So the result is like this, which equals to minus e to the power of e2 lambda t. And the third question is asked to find out T1, T2. So we assume that in the condition that of T2 is bigger than T1, and we know that xt1 multiply x1, xt2 can be 1 or minus 1. So the T1, T2 equals to expectation of xt1 multiply xt2. And we know that it equals to positive 1 multiply the probability xt1 multiply xt2 equals to 1 plus the minus 1 multiply the probability of xt1 multiply xt2 equals to minus 1. So and we know that in time interval T1, T2, k equals to k is even, we can make them to equal to each other. And if in time interval k is odd, and we can make them equal. So we can transfer the equation into this form, and finally we get the answer. So as the same rule, if we change T1, T2, make them like T1 is less than T2, we can just exchange the position of T1, T2. So in a nutshell, we can get that T1, T2 equals to e to the power of minus 2 lambda multiplies the absolute value of T1 minus T2. And the fourth question is asked if xt is wider than stationary, and we can prove that it is, because we know that in the third question, the conclusion of our T1, T2 equals to this equation, and we can conclude that the T1, T2 is only related with T1, T2. So it is wide stationary, wide sense stationary. So that's the answer. Thank you for watching the video.